Algebra 2. Welcome to our fifth video and this fifth video is covering part 3 of logarithms and logarithmic functions. So for the past 2 videos, we've learned how to rewrite logs as exponentials, and we've also learned how to rewrite exponentials as logs. But for this video, we're going to talk about how we can take log equations and figure out what they are actually equal to. Just let me go ahead and erase this real quick. So in this example, let's say we have log 3 to base 3 to the power 27 equal to y. But what number is y exactly? Is it y to the 7th? Is it y to the 5th? Is it y to the 1/3? Well, you can't be so sure right now. But today's video will help you determine what this value is actually equal to. Or in other words, we're going to figure out how to solve log functions. So with that, let's go ahead and get to it. So let's say we have these 2 log functions, and we want to ask ourselves, what value do they equal to? So first off, let's look at the one on the left, where we have log base 4 of 64, and we want to find out what that is equal to. So to start off, let's just take this log base 4 of 64 and let it equal to y. And to start off, let's do something that we've already learned before in our previous videos. Specifically, let's take a look at the loop method and see how that can help us. And just a refresher of how the loop method starts. First, you start at your base, in this case base 4, then you make a loop to the outside, and then you finish that loop right on back. And following that order, where we started with the base of 4 first, that means that's the first thing we're going to write. The y came second, so it gets written second. And then the 64 came third, so that's the last thing we write. So basically, all we've done was take a log function and rewrite it as an exponential function. And then if you take a look, we now just have 4 to the y equal to 64. And then if you look, this is just a regular exponential equation. And we've had plenty of experience with solving exponential equations last week, so this should be a piece of cake. So in other words, let's take a look at these 2 equations, or these 2 parts, and let's try and make their bases the same. And some of you have already had some experience with 64, where we know 64 is the same thing as 4 cubed. And that would actually be useful to us since our second base is equal to 4. So then let's just use that fact to rewrite our equation. So we still have 4 to the y, and let's replace 64 with 4 cubed. And just like that, our bases are the same. And if the bases are the same, just go ahead and set your exponents equal. And there you have it. We have y is equal to 3. So then just using the methods that we've learned before, we have just taken our log function, log base 4 of 64, and I figured out that that would be equal to y equal to 3. So let's go ahead and try that same idea with the log function on the right. So in this case, we have log base 6 of the fraction 1 over 216. and we want to figure out what that is equal to. So let's just go ahead and set that equal to y. We want to figure out what y is. So to help us out, let's use the loop method to help us rewrite this as an exponential. So start at your base 6, loop around to the y, and then loop on right back to the fraction. And since the 6 came first, it gets written first. The y came second in the loop, so the y gets written second. And the last thing that got written, or the last thing that was in the loop, was the fraction 1 over 216. That's the last thing that gets written. So again, we now have an exponential function, and let's just go ahead and solve for y. But of course, if you look on the right side of our equation, we have a fraction. And of course, in our previous video on exponential equations, we can rewrite this so that we don't have to deal with the fraction. More specifically, if you take the base or the bottom of your fraction, let's go ahead and rewrite 216 as 216 to the power of 1. And then, why don't we just take our fraction and let's flip the top and the bottom. And in doing so, this becomes 6 to the y equal to 216. But now our 216 has a power of negative 1. So that's what happens when you flip the fraction. It's no longer a fraction. The only condition is you had to make the exponent negative. So now, no more fractions. Let's just go ahead and find a base that will make our bases the same. And if you, after some experience, you will find out that 216 is the same thing as taking 6 and multiplying it 3 times. So in other words, 216 is the same thing as 6 cubed. So let's use that to help us rewrite our equation. So we'll have 6y equal to 6 cubed when you replace it for 216. But remember, 6 cubed still has the negative 1 on the outside. So now just multiply the 3 and the negative 1, and now you have 6y equal to 6 to the negative 3. There you go. We got the bases the same, so just set the exponents equal, and you have y is equal to negative 3 as your final answer. So basically, we're just using methods and procedures that we've learned from the past, and we're now applying them to logs. So it's basically not too much new information. Just taking old procedures and information and applying them to new types of equations. Let's go ahead and do one more, just so we get the hang of it. And after this one, you can go ahead and pause the video and try the last 2 problems in your notes and try and solve those log functions. If you get them right, then you can just skip ahead. If you didn't get them right, then probably watch through the rest of the video to see where your mistakes, what mistakes you made. So with that, I'll go ahead and finish this one, and you can start on the last 2. So let's say for this one, we have log base 16 of 4, and it's going to be set equal to y. And we want to figure out what is y equal to. So to start off, let's use the loop method to help us rewrite this as an exponential. We started off with 16, so 16 gets written first. The y came second, so the y gets written second. And the last thing that got written was a 4. So now we have an exponential equation. Let's go ahead and find a base that will match. If you take a look at these, we can see that 16 is the same thing as 4 squared, which is exactly what we want to make both the bases equal to 4. So let's go ahead and do that. 16 will then become 4 squared, with the y still on the outside. And while we're at it, let's take the 4 that's on the right side and rewrite that as 4 to the power of 1. So then the next thing we'll do, let's go ahead and multiply the 2 and the y that's right here. That'll become 4 to the 2y equal to 4 to the power of 1. Now our bases are the same, so that allows us to set our exponents equal. So in other words, we'll have 2y equal to 1. Then voila, just divide by 2 to get the 1 alone, and you have your solution. Y is equal to 1/2. So we just went through 3 examples of evaluating logarithmic expressions. So for now, go ahead and pause the video and try and solve these 2 equations. Go ahead and do so now. All right, we are back. If you did these 2 and you got them right, congratulations. If not, go ahead and watch me do them and make a note on what mistakes you made, so then you can reflect on them. So let's say for the one on the left, we have log base 3 of 81, and we want to find out what that's equal to. So let's go ahead and set that equal to y. And our main goal is to figure out what y is equal to. So to start off, we'll do the loop method so that we can rewrite this equation as an exponential. So in our loop method, the 3 came first, so the 3 gets written first. The y came second, so it gets written second. And the last thing in the loop was 81, so it's the last thing that gets written. So now we have an exponential equation, and we need to make the bases the same. So probably the best thing to do is to try to rewrite 81 as a base of 3. And if you haven't seen it already, 81 is the same thing as multiplying 3 4 times. So in other words, 81 is the same thing as 3 to the 4th. So let's go ahead and use that fact to rewrite our equation. So we'll have 3 to the y, and that's going to be equal to 3 to the 4th. And that's what we get when we replace 3 to the 4th with 81. So if you look, our bases are the same. And since the bases are the same, we can just set our 2 exponents equal. And voila, you have what y is equal to. Y is equal to 4. All right, then we'll do the last one, and that'll be it for this lesson. Make a little wall here to separate information. So for this equation, we have log base of 1/2 of 256, and we want to figure out what that is equal to. So let's go ahead and set that equal to y. And we're going to solve for y. To start off, let's go ahead and use the loop method to rewrite it as an exponential. In the loop method, the 1/2 came first, so it's the first thing we're going to write. The y came second, so it's the second thing we're going to write. And then last but not least, since the 256 came last, it gets written last. So maybe to start off, we should probably rewrite this fraction so that, well, it's no longer a fraction. So with the 1/2, let's take a look at the 2 on the bottom, and let's rewrite that as 2 to the 1st. And once we've done that, just take the 1/2 inside the parentheses and switch them around. And in doing so, that gives us 2 to the -1 on the inside. And we still have y on the outside. And then while we're at it, we still have 256. And then while we're at it, 2 to the negative 1 is still raised to the power of y. Let's multiply those two exponents. So we'll get 2 to the negative y equal to 256. Okay, so we no longer have our fraction. So now we just need to find a base, a common base for both of these parts. So it looks like we're going to have to try and rewrite 256 as a base of 2. And if you experiment with it long enough, you'll find out that 256 is the same thing as 2 to the 8th power. So using that fact, let's go ahead and rewrite our equation. We'll have 2 to the negative y equal to 2 to the power of 8. So now our bases are the same. They're both a base of 2. So now just go ahead and set your exponents equal. And you'll get negative y equal to 8. And then all you need to do is just divide by negative 1 to get rid of that negative in front of the y. And voila, you have y is equal to negative 8. And just like that, we've used not only the loop method, but also our skills of solving exponential equations to solve logarithmic expressions. So if you have any questions that you want to ask in class tomorrow, go ahead and write those down so that you don't forget. And also here is the assignment covering how to solve logarithmic expressions. If you want to go ahead and get started, go right ahead. And with that, I will see you tomorrow.